Sir Gregory Paul Winter, thank you very much for being here today. Could you elaborate a little bit about how did you come up with the different techniques of antibodies and what was the importance of humanizing monoclonal antibodies?
The importance of humanizing antibodies was that as mouse antibodies, when they were put into humans, they raised an immune response. So that meant that you made human antibodies that blocked the therapy. So the importance of humanizing was to try to make those antibodies less visible to the immune system.
Autoimmune disease have a myriad of altered cytokine responses. How did you decide to focus in the anti-TNF alpha therapy?
I should point out that I didn't decide to focus. The credit for this belongs to other people. So I was aware of work being done by a variety of groups in the field of TNF. They were interested in using anti-TNF antibodies to block septic shock. But that didn't work out. And in the early 90s, when we set up Cambridge Antibody Technology, we had a visit from Bob Kamen of the arm, an arm of BASF Pharma. It's the American arm called NOL. And he was interested in making an antibody, a human antibody against TNF. And I think the reason for this was he was aware of work from Tiny Maney and Mark Feldman in London at the Kennedy Institute, who had started to use an anti-TNF antibody to treat rheumatoid arthritis. And so the reason we started looking at that was it was becoming apparent that that was a very interesting antibody, or antibodies against TNF were very interesting, but it really came from other people, the idea of doing it.
We have talked about autoimmune diseases, but what other human diseases could benefit from antibody therapy?
Well, there are a number that already benefit. So, for example, osteoporosis can be treated with antibodies. There's the antibody denosumab, which has been recently launched, which is against the rank ligand. And this alters the conversion of osteoblasts and clasts, so it alters the balance in the equilibrium between them in favor of the osteoblasts and at the expense of the osteoclasts. And that antibody can be administered every 6 months, and it appears to be effective in controlling osteoporosis. There are other antibodies. One, I was involved in the early stages. The very first antibody, actually, that was humanized is an antibody called Campath-1H, also known as alemtuzumab. And this we developed in the late 80s in a collaboration with Herman Waldman in Department of Pathology in Cambridge, hence the name Campath. And that antibody kills both T and B cells. But it doesn't kill the stem cells. And a clinician in Cambridge in the early 90s called Alistair Compston started to use this antibody for treatment of multiple sclerosis. And his first experiments showed that actually it isn't terribly useful if it's used for treating the later stages of the disease, where it appears most of the inflammatory damage has already occurred. But if you use it for treating much earlier on in the disease, before you have the inflammatory lesions, then it can stop the progression of the disease. And so some very exciting results come from this work, which was done with Genzyme and which has now been bought by Sanofi, the French company.
Very interesting indeed. Could you let us know of your new work on bicycles studying ways to potentiate the effects of monoclonal antibodies?
The work with bicycles was started because we wondered if you could shrink an antibody into something much smaller. Now, some of the advantageous properties of an antibody are due to its large size. So, for example, it doesn't clear so fast from the blood, so antibodies can be given every 2 weeks or every month. The problem is that antibodies equally well don't perfuse into tumours well. And therefore we were interested in trying to make antibodies, or trying to make a mimic of an antibody that was very small and that could perhaps get into a tumour much more effectively than a conventional antibody, just by virtue of its small size and being more permeable. So what we started to do was to try to devise a way of displaying peptide loops on a chemical scaffold. And these end up giving you a bicyclic peptide. So essentially it's a 2-looped peptide, very tightly constrained at the center of the 2 rings. And these can be developed in much the same way that we developed antibodies, by using the phage display system. And these can have very high specificity and high affinity because we can screen vast libraries of them quite efficiently.
That sounds pretty interesting. Based on your whole career, which has been focused not only in academia, but also on the industry, what do you think are the most important steps to accelerate the translation from the bench to the bedside, from the lab to industry, in terms of effective products?
Sorry, could you repeat that? The most effective?
What are the most important steps to accelerate the translation from the lab into industry?
Well, I think it would depend on your background. So, in my case, for me, the most important steps were to have a reasonably open mind and to have some experience of industry. So I had done some consulting for industry before I started to set up my own company, Cambridge Antibody Technology. And as a result of that experience, which was both in dealing with large pharmaceutical companies and in fact in dealing with 1 or 2 very small startup companies, I realized that it actually wouldn't be that difficult to create my own startup company. And I think if I had not had that experience, I would have been too frightened to start on that process.
And today you are here for the first international symposium of the Spanish researchers in the United Kingdom. You have been invited to give the plenary lecture, and we are glad to have you here. But under your opinion, do you think the presence of societies of researchers from other countries in the UK potentiates or could potentiate the integration of science and society?
That's a very deep question. I think that there's no question that the development of a variety of societies, such as the Royal Society in London, was very important in the development of science in the United Kingdom, and in particular was very important in upholding the values of science with respect to governments. In your case, you've set up a society of Spanish researchers in the UK. again, if you stick to the basic principles of representing the interests of science, then I think it could have a very useful function. Although I imagine that a society of Spanish researchers in Germany could also be extremely useful and would give you a different dimension into the way science is done in that country. It's certainly true science is probably done in each country in a somewhat different way, and so I suppose you may get some comfort from talking to other people who are more familiar with how things work out in the UK, in particular how to advise other young Spaniards who are thinking of going abroad for a period of time, which I think is terribly useful, into coming to the UK, or perhaps they might be more temperamentally suited to going to Italy or Germany or the United States. And I think the availability of a number of these societies could actually help people choose what would fit their temperament best.
Thank you very much for all your answers. It's a pleasure to have you here today, and thank you very much.
Most welcome. All right.